All right, so today we are talking quantifying heat transfer when there is a phase change. So we are using the equation Q equals mH. So remember that Q, that is heat or energy. We measure that in joules. M, that's mass. We measure that in grams. And H, I'm going to switch my color here and draw an arrow so we can see it. But H is your heat of fusion or heat of vaporization. And that's these numbers here for water. You know we work a lot with water. So that's going to be a constant. So just like specific heat capacity, it's different for different materials. And we have a heat of fusion. That is for melting, which would be positive. Freezing, which would be negative because we have to put energy in to melt something, it's endothermic. But to freeze something, we have to take energy out, it's exothermic. Same for heat of vaporization. That would be positive for evaporating and negative for condensing because we have to put energy in to evaporate something, but we have to take energy out to condense something. So that's really important that you pay attention to those signs. Remember that Q is a vector value. It has a magnitude and a direction. So that positive or negative tells us heat in or out, endothermic or exothermic. That's really important. So keep that in mind. Okay, so let's check out this first problem here. So suppose during volleyball practice you lost 1.0 kilograms of water. Okay, so when I see kilograms, I think, oh, that's a mass. I also think I need that to be in grams. There's 1,000 grams in a kilogram. So this is 1,000 grams. Now you note that this is 2 sig figs. This is only 1 sig fig. I could write this as 1 sig fig. It'd be 1.0 times 10 to the third grams. I don't want to mess with scientific notation, so I'm just going to remember that that's 2 sig figs. I am allowed those 2 sig figs, even though it's kind of hard to write 1,000 with 2 sig figs. All right, so we lose 1 kilogram of water due to sweating. If all of this water is evaporated, how much energy did the water absorb from your body? Express your answer in kilojoules. Okay, so this equation is pretty simple. So we're trying to calculate energy. That's Q. So Q is our question mark. So Q equals the mass, 1,000 grams, times, we either need the heat of fusion or the heat of vaporization. Well, you're sweating and it tells us the water is evaporated. So that's important. It's evaporated. So that means we need the heat of vaporization. And it's evaporating, so it's going to be positive. So I multiply by 2260 joules for every gram. And you see when I do that, grams cancel, so I end up with joules. So I am left with 2260, 1, 2, 3, multiply that out. So I get 2,260,000 joules. You can see why we want the answer in kilojoules because that is a very large number. So we can simplify things by dividing this by 1,000. And that will get us into kilojoules. So that gives us 2,260 kilojoules. But of course, we got to do those sig figs. I'm going to round this to 2 sig figs. This 1.0 kilograms has 2 sig figs. So that's going to give me 2,300 kilojoules as my answer. And that is positive because it's being evaporated. So that is endothermic. If this was being condensed, we would have used negative 2260 and our Q would have been negative because heat was leaving. So that's the only thing that you really have to pay attention to here is one, make sure you're using the right H, make sure you're using the right one, heat of fusion or heat of vaporization, but also watch that sign. So make sure you decide whether it needs to be positive or negative. It can't decide for itself. You need to be smarter than your calculator. You need to tell it whether it's endothermic or exothermic. And that's 3.7.